Okay, today we will start to introduction to CAM, computer aided manufacturing. In this semester, we will talk about computer aided manufacturing and computer aided engineering. So at least until the mid semester, we will study about computer aided manufacturing. And I hope all of you have a software of CATIA because I will to teach how to generate CNC code that is very important to CNC by using CATIA. Okay, for the definition, the manufacturing, the correlation between the operations and activities, which includes product design, material selection, planning, production, inspection, or quality control, and management, and also to marketing. A manufacturing production after the fabrication process, design, and product planning activities, among other stuff, casting, forming, and machining or material removal. In this subject, we focus on machining or material removal. As we see in the product cycle, by using computer-aided design and computer-aided manufacturing, we can continue from product concept to the design of engineering until to drafting. For the last semester of the previous semester, we already conducted the drafting or technical drawing. And in this semester, we continue to computer-aided design and manufacturing. So when we talk about the cycle of production, the position of CAD and CAM is in production cycle. We see after drafting, continue to process planning, and then production scheduling, then production. So the position of production is by using computer-aided design and computer-aided manufacturing. And then after production, the product was generated and come to quality control. If a pass from the QC, then continue to customer and market. So we see the position of CAD and CAM is in a production stage. We know that the machining cycle of CNC, starting from computer-aided design, we prepare the design of product in 2D or 3D. For the lead machining or for the turning, you can prepare the design in 2-dimensional or 2D, but for the milling, for example, surface milling or 3D milling, the design should be prepared in 3D. As we know that there are several types of 3D design. For example, solid design, surface design, and wireframe. For the milling 3D, you can prepare in surface or in solid design. After you finish the design, then you continue to machining simulation by using computer-aided manufacturing. In here, you can simulate the movement of tools using software, for example, CATIA. So all of you have to install CATIA in your own laptop or PC. So in the machining simulation, you can see the movement of tools, but in turning or in milling. From the simulation, you can check of tool movement. If there is a mistake or violation, for example, between tools and part and on the component such as the machine or table, you can modify your data or your parameters of manufacturing, then you can continue the simulation until there is no error or no mistake using simulation, and then you can continue to generate NC data. NC data usually called as a G code because there are many G in the code of the numerical data. And then the numerical data is sent to the machine, especially for CNC machining. And then the CNC will read the numerical data and run in the machine to control the movement of tools, the tables, and etc. And another CNC milling, for example, this is a multi-axis CNC milling and 3-axis of milling. The differences of these machines is on the number of axes. For 3-axis, there are 3 axes, X, Y, and Z. For example, the Z-axis is the movement of tools. This is for the vertical axis. And the X and Y axis is for a table movement. This is for table in CNC milling. And then for the multi-axis, there are 2 axis addition here. For example, here, this is the W axis and B axis. So there are X, Y, Z, and W and B. B is a rotation on the tools, and then the W is the axis movement of the tools. This is different with the Z. Z is still in the vertical, but for the W movement, it depends on the tool positions. And then the basic of numerical control. Machine control with a variable data input from a floppy disk or another storage such as USB and etc., or even integrated with CAD/CAM system, named as a numerical control or NC. NC have been determined by the Electronic Industries Association as a system that works with control by numerical data is entered either manually or automatically. Therefore, every CNC must have MCU, machine processing units, which consists of 2 main parts, the DPU, data processing unit, and CLU, control loops unit. DPU or data processing units, this part is used to read data storage, such as a floppy disk, CD, floppy disk, or USB, and etc., even directly from the unit of CAD/CAM. DPU contains of manual data input device, so you can also manually input the data, and data input reader, and also editor device to make editing in the input data. And then CLU, control loops unit. This section serves as a motion control motion mechanism on the machine or CNC. The CLU contains of interpoler, which serve to supply the machine movement. Command include motor to produce movement with precise distance. As we know that the CNC can move with the distance of 0.001 millimeters or 1 per 1000 millimeters. You can imagine all the precision of the machine. And number 2, control loops position for all X motion machine. Therefore, it do not lose the position or the position coordinate of the tools. This is the diagram of movement control command of NC, starting from NC program or NC data that we have prepared before by using computer-aided manufacturing, and then sent to the CNC. There is interpolator and servo control mechanism, and then control logic with the power to control the linear motion. And for another translator, relay and solenoid and power connected to control logic. The classification of numerical control, motion control, but the motion and the motion of point-to-point contouring. And then the second is control loops. There are open loops and closed loops. And power, for example, hydraulic, electric, and pneumatic. And then the placement system, it's called P absolute and incremental. And then the fifth is hardware and software of CNC. And then continue to the CNC TU3A. TU mean training units, and 3A, it's mean 3 axis. This is a Frais machine, CNC machine, Frais or milling machine. The training unit of 3A CNC have 3 axes. This is only for educational machine, and the engine control unit using MCO, the name of company that produces this CNC, and have 3 axis motion, X, Y, and Z, but only 2 axes can move simultaneously or concurrently. You see, only 2 axes. This is a very simple machine. So it means that only 2 axes that can move simultaneously. And the tool movement of CNC TU3A, the tool movement, for example, the Z axis is for up and down movement. This is for tool movement. And then table movement for the CNC TU3A is for the axis X and Y. So for the figure, you can see we have X, Y, and Z. Z is vertical movement, X and Y is in the table movement. And the accuracy of CNC TU3A is 0.01 millimeter or 1 per 100 millimeter. This means that the machine is able to perform motion with 0.01 millimeter spacing. To make easy in entering data, the data is multiplied by 100. So to enter the 1 millimeter data, you can write in 100. Okay, this is the introduction of CAM for the first meeting. And today I will continue to the second subject or second discussion about the